Energy is a scalar. However, when you relate it to two-dimensional motion, which is what we've been doing here, you have to determine how much of that energy is used in each dimension. For example, a marble launcher shoots a marble vertically, so that would be like this, straight up, and then shoots a marble in the horizontal direction. Are their exit velocities the same? Now here's our little marble launcher here, so we've compressed the spring, right? Let's say this spring gets compressed to that point. Then we release it, it travels like this, and then the marble pops out. It either goes this way for the horizontal or this way for the vertical. In both of those cases, the initial potential energy is the same. All right, so we're just going to go ahead and draw the marble launcher there, compress like that, and then it goes up, and here's the spring. And for the horizontal, same thing, and then it goes that way. However, let's look at the vertical case. All of this elastic potential energy, some of it goes into you have to go up this distance here. So some of the energy is transformed into gravitational potential energy. So by the time the marble leaves, it's lost some energy that's gone into it hasn't lost, it's been transferred into gravitational potential energy. So there's less available energy for KE. So KE loses a bit. Over here, you're at the same gravitational potential energy as when you started. So your marble is not transferring any of its energy to gravitational potential energy. So it all goes into kinetic energy. So therefore, more kinetic energy, greater velocity. Therefore, if you're going to launch a marble and you want a higher exit velocity, aim it horizontally. And of course, if we have another case where you're shooting a marble like this and you want to know how high it goes, well, we know that at the peak, the y velocity will be 0. But what do I use for the velocity? Do I use this for the initial velocity? No. You have to resolve it into x and y and just use this vector here as your initial velocity. And then use v squared is v0 squared plus 2a delta y, where your final velocity is 0. The initial will be this v0 sine theta, and that'll tell you how high it goes. So not all the energy goes into making the marble go up high. Some of it makes it go in the x direction.